Welcome to lecture 2 on FPGA architecture and programming technologies. So, what is FPGA? FPGA stands for Full Programmable Gate Array. It is a powerful reprogrammable logic device that allows designers to implement complex digital systems. So, it is an overall IC which contains nearly about 64 to over 10 cores of identical logic cells, which can be viewed as a standard component. So it is a logic set which can perform Boolean functions and are also interconnected using the matrix number of bytes and programmable switches. Due to this reason, this flexible interconnection fabric makes FPGA to be more suitable for a wide range of applications from simple digital circuits to full SoCs. So coming to next slide. So what are the basic logic blocks of FPGA we are going to discuss? So at the heart of every FPGA are the logic blocks, but also called as configurable logic block, that is CLB. So each logic block consists of two essential components, namely LUTs and flip-flops. So what are LUTs? The full form of LUTs are lookup tables. That means these are the small memory areas that store truth table and can be implemented in any combination logic function. So what are flip-flops? These are used to store binary data, which will enable the design of sequential circuits. So in overall, LUT computes output based on input combination, while the flip-flop will store the logic state as a 0 or 1, enabling synchronous digital operation like registers or counters. So LUT is still the small memory area which contains the truth table and the flip-flops are used for storing the data. So, what are the next part of logic FPGA? These are the interconnect. So, what you mean by interconnect? So, the logic flow don't operate in isolation. These are connected using the interconnect fabric. This interconnect consists of programmable routing resources, which are basically bytes and switches, and that can be configured to route signals within the logic blocks in FPGA. So this is what we make the FPGA more flexible and powerful, and also it can mimic almost any digital hardware behavior simply by programming the connection between the blocks. The next part is configurable input-output block. Let us talk about the interface. These are all about the middle part. Now, what are there in the interface of the FPGA? So FPGAs have configurable input-output pins. That means it allows the interaction between the external devices such as the computer or any outside devices. So these are connected by the peripheral device of input-output pins which are configurable. These input-output blocks can be programmed to act as input, output, or bidirectional. What you mean by bidirectional? It can be act as both input pin and output pin. This flexibility enables FPGA to connect seamlessly with other digital components like memory, sensors, processors, and all other peripherals. This is the overall architecture of FPGA. Let us summarize what are the FPGA consists of. Programmable logic blocks for computing logic, or in short we can call it CLB. And also the interconnect resources. You can see in the middle part there are square boxes which can use for routing the signals, and input output block for external communications or input output pins or bidirectional. Together they form a programmable chip that can be configured to perform any digital function. So this architecture makes FPGA more suitable for prototyping, high-speed processing, signal processing, and even artificial intelligence tasks. So let us take a few minutes to see the FPGA architecture. These are the horizontal and vertical lines are the routing resources to transfer the signal between the peripherals. These are the PLD multiplexer, D flip-flop, 2:1 mux, 4:1 mux, and number of mux you can have as a PLD. And these are the LUTs. As I discussed, these are the lookup tables which contains the truth tables, and a multiplexer for controlling the output. So there are Various different FPGA architectures. Different FPGA vendors offer different architecture. Just like we have different types of TV that are different vendors. Similarly, FPGA architecture differ from one vendor to different vendors. Some use hierarchical routing, some provide hard IP cores like DSP blocks, memory, or even ARM processor. For example, we have Xilinx and Intel, which were earlier known as Altera, that offers FPGA board with different architecture optimization. Understanding this architecture will enable the user to use right FPGA for the particular application in terms of speed, logic density, and power. Now, there are various FPGA programming technologies. Let us have a brief overview about this. This can be programmed using different technologies, each offering unique advantages. Each one will have different. There are three major FPGA programming technologies, which are one is MPQ based, the second one is SRAM based, and the third one is EEPROM based. So what are the three types? One is MPQs, SRAM, and EEPROM. So let us look at each one in detail. First, we'll discuss about the MPQs based FPGA. First, we have MPQs. Here, the programmable elements start as open circuit and program a high voltage permanent grid connection, essentially blowing the empty grid. So what are the key characteristics? The configuration is non-volatile. That means it retains its logic even when the power is off. It is not like volatile, it is involatile. The program is permanent in the MPQs based FPGA. That means once we program the code in any device, thereafter we cannot change the design at any cost. So these are basically used in the aerospace, military, and safety critical systems where security and reliability are too much essential. So they have high power consumption and are not suitable for application needing frequent design change. That means suppose you want to make a design and you want to frequently change the system, this type of FPGA are not suitable at all. Mostly they are used in the aerospace system. Next, now coming to second FPGA technology. So let us go in before SRAM. Let us see the logic diagram of MPQ space. Let us take a few minutes to see about this. Now come to SRAM based FPGA. The system most widely used type today because this is the volatile. That means the configuration is stored as well as it can be reprogrammed again and again. That means the logic will not be lost on power off and must be reloaded every time from an external class of computation unit. So what are the advantages? These SRAM-based FPGA are even frequent can be reprogrammed. These are ideal for design, prototyping, and development. They can be configured and can be dynamically updated. Also, these FPGA using communication system, AI, accelerators, signal processing, and more. This is the EEPROM side, this is the SRAM side. Now the third type of FPGA programming technology is the EEPROM based FPGA. These are the erasable programmable ROM, which can store the configuration. The stored configuration is even after the power is off. That means it is non-volatile nature. But reprogramming requires ultraviolet light exposure to erase the previous data. Because of this inflexibility and slow update process, EEPROM-based FPGA has largely been replaced by SRAM and NTFS technologies. They are now ready using modern design because although they are volatile and they program, but easily they can be reprogrammed. Once the code is given, it takes we need ultraviolet rays to erase the previous data and to reconfigure them, which is very cost effective. But in working case of SRAM, we can erase the data by computing low power application. So in general, we are using SRAM based computation everywhere instead of EEPROM. And anyhow, MPQs programming language are using the higher application where security is more concerned. Now we discuss about what are the FPGA, what are the architecture of FPGA, and we first on the design of FPGA and what are the various blocks and what are the applications of various blocks and what are the inputs of various blocks and how they are configured in the FPGA architecture we learn. So In conclude, what we can say, FPGA is a versatile recomputer platform used to discuss system implementation, and also it contains the core components like logic block, interconnect, and input output. Also, FPGA can be programmed using multiple SRAM or EEPROM technologies if it is phased out. You can see the component table here. SRAM is a volatile, instantly reprogrammable. It contains larger area with a medium high resistance and high capacity. Coming to EEPROM, this is a non-volatile but out of circuit is programmable. It is very difficult to erase the previous data by simpler means. It is a lot easy ways to erase the data and the resistance is very high, capacity is high. Coming to one more is WFM or flash program technology, which is also non-volatile, interpretable, in the area of the medium to high, resistance will be high, and capacity is high. Last but not the least is anti-fuse, which is non-volatile, not reprogrammable also. The area occupied is small, resistance is small, and the capacitance is small. So in this lecture, next lecture we are going to see in deeper in FPGA design flow and tools used for implementing digital system or on hardware. Thank you for your attention. Thank you for your attention.